In this section, I want to talk about this portion of our study. We are going to talk about some IP operation, and actually they are some part of ICMP operation. And ICMP is an acronym for Internet Control Message Protocol. There are some messages that are sent between routers and other devices, of course, that are enabled for TCP/IP. And using these messages, they will, report some kinds of problems, some kinds of, uh, different information to each other. So what is unreachable and what is redirect? I want to show you an effect. And for this, I need to, create a kind of, lab. But for redirect, I do not have anything to show you the redirect actually. What I'm going to do is, to draw a diagram for you and give you information about redirect. Supposing that this is my lab, and let me color it in white. This is my LAN, and I want to move it down a little bit. And in this LAN, I have two routers, for example, and I have one device. This device is a computer here. This computer is connected to my LAN using a link. Now, I have two routers connected to this part of network. One is connected to the outside, this part, for example, one ISP, and another one is connected to another ISP. So this is one of my routers, this is another router, and these are two different ISPs. And of course, I have internet in between. And assuming that this is internet and this is internet 2. Okay, there's a server on this side. And of course, you know that internet is kind of multi-route web for us. But I assume that this is a better way to reach this server. You know that we can reach to the server from other sides too. So I have router 1, I have router 2, this is my server, and this is my computer. So computer 1 is configured to have router 1 as its exit point. And for this, I just write default gateway is, for example, 10, 10, 10, 1. This one is 10, 10, 10, 2, but the default gateway is this one, rather 1. So when a client tries to send a message to server, it will just go to 10, 10, 10, 1, and 10, 10, 10, 1 is directly connected, or at least it has a lower cost to reach the server, and that's okay. What happens if I configure router 2 as default gateway? Actually, a client tries to send the frame to server using router 2. Router 2 checks its routing table and sees that router 1 is a better option to send and transfer the frames to the server. So it will first of all give a message to computer 1. This message is an IP redirect message. And it tells computer 1 to use another router to reach to the server. Actually, it tells computer 1 that router 1 is a better option to use if you want to reach the server. This is what IP redirect means. And it has only one command under this interface, for example, and that command is IP redirect. That's it. And I guess that is on by default, so you do not have to, type this command. What about the other message? The other message is ICMP Unreachable, and this is uh, best shown when we work in our lab. For example, I have a connection between router 1 and router 2. Let me check to see if there is any routing protocol configured between these two. If I check IP protocol using show IP protocol, you can see that there is nothing configured here. I just want to show IP interface in brief, and these are my interfaces. As you can see, I have a loopback 0, And because I don't want to go for any routing protocol, first of all, I just want to write a route to reach to 100, 200, 2. Let me write this. IP route 100, 100, 2 with a mask of 255, 255, 255, 0. And the next hop is going to be 10, 10, 12, 2. And I want to make sure that I can reach to 100, 100, 2, 0. And from the other side, I write another static route, IP route 100, 100, 1, 1, actually 1, 0, 255, 255, 255, 0, and it should go to 10, 10, 10, what was the 10, 10, 12, 10, 10, 12, 1. Okay, now I should be able to ping look back interface of the other side. Using ping 100, 100, 1, 1. You can see that the ping is successful. And I can, of course, issue the ping from my own loopback interface using source loopback 0. And again, you can see that the ping is successful. Okay, I have connection and everything is working just fine. What happens if I go to router 1 and create an access list? I type access, access list 1 deny 100, 100, 2, 0, 0, 0, 0, 2, 55, access list 1, permits any. And I go to interface fast 0, 0, and write IP access group 1 inbound. Now if I go to router 2 and try to issue the ping again, I will receive unreachables. As you can see, this unreachable means that on the other side there is such an IP address, but it doesn't let me go in. So there should be kind of, for example, access list on the other side. So as a hacker, that's a very nice information for me. That's a very nice piece of information. That's because I know that I have guessed the IP address in a scheme correctly, and I know that there is something in between, and I can, bypass that. What I should do on router 1 as a security precaution, I should go under the interface level configuration and write IP ICMP, and actually no IP ICMP unreachables. Unreachable. Let me write no ICMP unreachable or no, that's it. No IP ICMP. Why can't I find that? No. Oh my god, that's gonna be no IP unreachable. Huh? Oh, that's it. No IP unreachables. You can see that if I enter this command under this interface and from router 2 again try to ping this uh, interface, you can see that instead of receiving unreachables, I receive timeouts or, unsuccessful or something. And based on this, I cannot tell anything about the destination. So unreachables, they give me a nice piece of information, but of course they give the hacker nice pieces of information. So you are not going to let any hacker know about this. Now, what about the fragmentation part? I just want to talk about fragmentation too. As a network, we have different network types. Actually, we may have Ethernet, we may have token ring. Of course, token ring is not so, popular these days, but actually it's time power network. We have, for example, point-to-point links, we have frame relay links, we have a lot of different types of networks. When we are going to send data in these types of network, we have to make sure that the amount of data that we send as a frame matches their design. Ethernet accepts about 1500 bytes as of one frame. In token ring, it may be different. And other type of networks such as ATM, FTDI, or other type of network, that may be different. You know that in ATM you have 53 bytes in a frame. So you can see that the frame size is so different. When we are sending information, of course, we are not going to, create all frames with the same type, with the same size. We can, create 100 bytes frame. We can create 1000 bytes frame. So frames can be very, very, variable in size. And of course, you can see that if you go over some specific amount of, frame size, you will encounter some types of issue, and I want to show you how this happens. I just want to go to router 1 and remove this access list. So no IP access group 1, of course no access list 1. I'm going to remove this access list as well. What I'm going to do is to reduce the size of MTU in one of my interfaces under pass00, I type this IP MTU, and you can see that the maximum is 1500, the minimum is 68. Lower than this, we assume that the frame is a runt frame. It is a damaged frame, or it is kind of a bad frame for us. So I just type, for example, 500 for my MTU. So what happens if I try to receive or send bigger size of, sizes of frames here? Let me go to router 2. This time I issue the ping again. Again, the protocol is IP, the target IP address is 100.1.1, repeat count is okay, datagram size is going to be 1000 bytes, and timeout is okay, but this time I want to go for extended commands because I don't want to, let fragmentation type of services. Okay, set df bit, yes. This is called don't fragment bit. This means if this frame is going to be sent, it should not be fragmented. It should be sent in one chunk, in one frame. Actually, the frame size is going to be 1000 because this is what I have configured in the datagram size, and I'm not letting this router to cut this down into pieces. So I hit enter, the validate reply data, it is okay, and everything is okay. And now you can see that the ping is not successful. That's because the other side does not accept more than 500 bytes in a frame. So you can see that IPMTU, plays a good role in some links, but I'm not going to set it on Ethernet. Actually, on Ethernet 1500 is quite okay. So if I type no IPMTU, IPMTU is going to be 1500 by default. If I try to issue ping from the other router, that's going to be okay this time. And what about the other topic? The TTL. Actually, on IPv4 and IPv6 fragmentation is done the same way. IPv6 fragments data like IPv4, and decides that it decides to fragment the data is different. I'm going to talk about sizing, fragmentation size later. But what about TTL? Let me give you a very very short information about TTL. You know that if I go back to my paint, you know that I can have a large number of routers in between me and my destination. For example, this amount of routers, this is me, and this is the destination computer, and I just write it computer 1 and computer 2, and it is connected to this way. If computer 1 wants to send a frame to computer 2, it gives a time to live to this frame. The time to live is 255 by default. So this is my time to live, or TTL. When it reaches router 1, it reduces the TTL by 1. It comes to 254, and it sends it to router 2. And router 2, again, it reduces 1 from this, and the new TTL is going to be 253, and it sends it to router 3. And it goes and goes and reaches the computer 2. It is 252, 51, 50, 49, and computer 2 receives that with TTL of 249. So what happens if I have a large number of routers in between, or for example, my message starts to loop between two of these routers. For example, there is a link between router 1 and router 3, and the message goes from router 1 to router 2 sends it to router 3 decides that the best path is router 1, and so there is going to be a loop here. If such thing happens, the TTL is going to deplete. Actually, this is going to become 0. And of course, when TTL is 1, the router is not going to transmit it again. So I will have up to 254 router in my way. And actually, this is not the case in most routing, processes. So this is kind of a loop prevention mechanism. So if we have kind of a loop in between, our frame is not going to, move them forever.